what's all that? That's my cat, Shadow, making a break for it now. Scratching up the posts of my bench here. That's how I'm starting my day. Okay, so it's been quite a few days since I've worked on this radio now. I've been doing other things in my shop. One of them is working on this decade box, which did not work out at all. And I've also been trying to advance on the radio, and again, that hasn't worked out at all, so I haven't posted any video of my frustrations. And what are the frustrations? Well, I'm still just looking at these old capacitors and wanting to change them out, but I've adopted a new practice, which is to substitute them briefly with a decade box like this, and then mess around and see what I can find out about the radio by operating it with what I guess could be called inappropriate values of capacitance in certain circuits. And in fact, even zero capacitance. Just remove the capacitor, run the radio, see what happens. I don't want to do those things unless I know for sure what this capacitor or any one of these is doing. A couple of cases have been easy. Just look on the schematic, there it is, and presto, I go ahead and do the thing. But I've spent quite a bit of time trying to identify this capacitor, and no luck. This one, I can't remember now. This one, no luck. I cannot find these two capacitors on the schematic. Now, there's a really high chance it's just I just haven't figured it out. I'm a little bit confused and it's just not coming clear, and there's really no issue here. But what it's doing is it's just making me not move forward at all. I haven't gotten anywhere. Here, I haven't posted the nonsense videos I've made about this. So I think what I'm going to do is I'm going to take another shot, because it's a new day, and sometimes when you let a day go by or a few days go by, things for some reason fall into place easier. So I'm going to take another shot at trying to identify these capacitors. I think I'm going to start with this one, because I think this one I think I can do this one. I think it's pretty straightforward, and we'll just go from there. So let us identify that capacitor. Making sure my video is running, because part of it's frozen here. Okay, back in my shop after drinking coffee, and look who's come with me here. For some reason, Shadow is staying close to me, and I wonder if it's because Peanut is not feeling well. He's laying low upstairs. Okay, this capacitor. So the easiest thing to do is to try to trace out a component is identify something it's connected to that will appear on the schematic without any question. So look at this capacitor. It's connected to this tube here, but this is a grounded pin. There's a ground wire and a connection made here. So this is really just tied to the chassis, and it's using these pins to do it. These are all tied together here. That's not going to help too much, because on the schematic they could show that almost anyway. So they won't show it based on the pin number. But the other side of it, and this is why I'm having trouble, the other side of it goes to this second IF transformer. Now what else is on there? Let's take a look with this camera, see if we can see what we need to see. Okay, I can see the wire coming down. Can you hear my cat purring? I can just have to move this. Well, it sure looks like it's attached to that pin that's just under the resistor there. Nothing is attached to that pin. Get the light going here. It's attached. There. Now we can see clearly what it is. Look at that resistor. I never. That's not looking too good, is it? Is it a resistor? It must be. Okay, so it's attached now. See, these have letters on them. E, F, G, A, is that A? A. B. We're on B. on B. Yeah. Okay, so it's on the B terminal of the second transistor or transformer. I wonder if those terminal letters are going to show up on the schematic. Now what else is attached there? Well, that resistor I just commented on, this thing here. So there's a resistor going across. You can almost read the amount here. My finger in there. Give it a finger cleaning switch. It looks like red, red, green. That'd be 2.2 megohms, I think. Okay, capacitor is attached to 2.2 megohms on pin number B. B, yeah, I'm pretty sure that's B. Okay, well, that's the hint. Let us go look at the schematic now. See if we can sort that out. So the second IF is here. They do have letters on them. Where's B? So look at this one. C, H, G, and D. C, H, G, and D again. I wonder if these letters actually mean something. G, grid? No, but it doesn't go to a grid. I don't know. But what happened to B? Well, that didn't work. Okay, so here. Maybe it's D and not B. Here's 22. Well, this is 22K. So this would be red, red, orange. That's not what I saw there. What I saw there was red, red, green. Okay, well, where is it then? Red, red. So, you know, that's a red, red, green. It's attached here. Oh, on the other side of this. Well, you know, this is how it's gone. When I've been trying to track these capacitors down, it's gone just like this. You know, there's one right here, a 0.0018. That's an odd size. Is that going to be a wax and paper capacitor of that size? It's connected to D and going. Oh, F. There's another letter out here. F. What's the F mean when there's a ground symbol here? What happened? Did the draftsman drop an F here by accident? Or maybe what it really means is if you're looking at the schematic and you finally get to this point, you're effed. That's what that means. Well, is it D? Is it a 0.00018? What a precise number too. So the purpose of this capacitor is to put a signal ground at the bottom of the coil here, rather than have the signal passing through here and finding its way to ground through some long journey. Just tuck a nice ground connection right here, but only for the signal, not for any DC voltages. I don't know, what do you think, Shadow? You're purring away there. Okay, I'm looking around on the schematic. Nothing else is coming to the fore. You know, different schematic from the radio I've got. I've got the 14B. Tuning ion model 14B only. So that's what the B is. I think the B is this tuning eye. And these can be added to a radio without much influence to the rest of the circuitry. So you could design an entire radio and come along and go, how about a magic eye? And you could pop it in. You could figure out how to hook it up and pop it in. Draw a little bit of current for the heater. That's about all though. So I wouldn't expect, so the bottom line of that is I wouldn't expect the rest of the schematic to be any different between the A and the B model. I've got the, I don't know what I've got. Okay, let's go back and look at this capacitor. See if we can see the size. See if the D is actually an F. That doesn't make sense. See if I can see that F is grounded, and what they've done is they've hooked up the capacitor to an alternate ground location. which I think is right over here, but I'm not sure. Okay, here we go. I'm going down just like the other capacitors. I'm going down. I have that sinking feeling. Okay, let's get in there really close. I'm going to fix the focus on this camera before we look through it again. Literally fix it. I'm going to take it off autofocus here. Just bear with me a moment. Hey, the weather here. So we've been through the whole Christmas period with weather, unusual weather, unusually warm, no snow, rain falling in fact, and above zero. All the way to here. Now the temperature here in Aurelia is hovering around zero or just a little bit below, and there's a dusting of snow outside. Oh, I might just have to concentrate here on what I'm doing. Okay. So, but they promise lots more snow coming. Yeah, right. Okay. So there's the capacitor. There is the wire. Just got a shadow no matter what I do here. Oh, it's Shadow. Shadow my cat. Okay. So I'm going to wiggle the capacitor. There's no question that's the wire going to the terminal. Now can we read the terminal? So that's a B, not a D. And B does not appear. What about this F? Here's F. Well, it's a bare wire, so I bet you it's going to ground. Yep. Going to this ground terminal here. Capacitor essentially going to the same ground terminal, just pictorially it doesn't match the schematic, but electrically it's exactly the same. So the capacitor that's shown on the schematic using this as a ground point, using F as a ground point, is almost certainly this one. Now we're going to look at the size of this because it was such a weird size. I'm bound to change this so I don't really have to worry about moving it around. She's a dusty phone. Okay, let's throw the camera. Cut them right out. We're going to cut it out. Okay, now what do we got? We got one dirty capacitor here. Let's look at it with that camera. 0.00018 is what is on the to scratch this pretty thoroughly to get the numbers up. That's a job for the Nordic fish knife. Capacity. Where's the value? Well, pretty clear. 0.05. What's with the yes. Well, that's way off. That's no 0.00018 capacitor. What is this capacitor supposed to be doing now? Do I know for sure which one it is? Oh my gosh. Let's look back at the schematic again and really build in the confusion here. Okay, so I was thinking the one I just cut is this one. But it's clearly hooked up to terminal B, which doesn't appear. So B is probably a spare terminal, because they do that with these things. They come with, some of them come with spare terminals to help out the radio designers. And so they did. But this is on D. Well, what's on D in that radio? I didn't really look, did I? I should look to see what's on D. And then the resistor that's connected there is 22 green. It's red, green. Oh my gosh, that's this, whoop, what happened there? Oh, a cat just stepped on my keyboard here. Oh, it's even a better arrangement, thank you. You went by and stepped on F11. Very good. Thank you, cat. He knows better what I'm doing than I do. She knows better, shame on me. Okay, so what's going on here is that this schematic is actually significantly different. This 2.2 meg is actually sitting in this position, which is not impossible, although you would tend to, well, no, you wouldn't want to put this great big resistor here, because it's going to drop the audio signal, which you're trying to get all the way over through the volume control and onward. So you wouldn't do that. So I don't know what's going on. I am totally befuddled here. So other than putting a 0.05 back in there, what is there a 0.05 sitting around here? There's one over here. That's a 005. That's not an 05. Here's an 05 here. Oh, get off my keyboard there, cat. Every time she goes by. Okay, I'm in control here. So could it be this one? And there's D. No, but it's B, Jim. It's a B. It's not a D. This is a different transformer. Do I have them mixed up? Is what I think is the second is really the first. I can't believe that. It has to be the second. It's feeding right into this tube. So we have to be looking at this. Oh, really? This is what you're going to do? Well, I can't be sure at all what this capacitor is. Oh, I'm going down the rabbit hole here. Okay, let's see where this capacitor was going. A little further on the circuit. So it's connected to this wire here, which I've cut. Connected to that pin, and then there's this moldy wire here, going all the way up to another terminal on the other IF can. Then from there, one lead, it looks like it's headed for the magic eye. I think so. I think this, often the magic eye leads kind of spill into the radio. You can see them coming through here. They kind of, they're all distributed out. It's pretty easy to spot them. Come in from the top. So that's interesting. Why would the magic eye be connected there? And we can look at the magic eye connections on the schematic. Again, this could be a spare terminal, and that could be a spare terminal. They don't really appear on the schematic. So, but the connection up to the eye would. And we don't know what eye connection this is. I think there's another moldy wire. It carries on way up. Way up where I can't see it here. It's this wire here. Two moldy wires are in contact. I think it goes into the switch, which is not going to be very helpful at all. Holy smokes. I can't believe I cannot identify these capacitors or even where they are in a circuit. Let's take a look at the Magic Eye and just, Magic Eye is going to have 4 or maybe even 5 leads coming down from it, so sorting that out is not so easy either. Let's take a look at let's calm down and see what we can see. It's me who has to calm down. Okay, so Magic Eye. Funny, I was just talking about it. So here is the Magic Eye. So we have a heater connection, which is doubtful that's what that is. We have a couple grounded connections. The wires going back into the set. There'll be 1 to catch the ground, 1 to catch the heater, and 2 more. So 4 wires. So we pick one of them. Pick this one, and it's connected on the. It's connected to the. This is the AVC pickup wire, if you like. It's picking up the AVC voltage here, and using that to control the eye. And this is going to be plate voltage coming over. Pretty sure, yeah, right out of the power supply here. So, is there a 0.05 on the plate wire? Oh my gosh, it could just about be anywhere in the radio. All the way up to here. I don't see any. Looking for a 0.05. Show me a 0.05. No. No. I don't know what to think. Either I'm just not getting it out of this radio, or there's a substantial difference between this schematic and the radio. Huh. Well, I'm going to have to follow an alternative approach, which is one I don't like to follow, which is just like for like. You just take out the capacitor and put the same size back in and don't worry too much about any of it. I'm going to have to do that because this is just going nowhere here. I've wasted a ton of my time on this. Okay, let's give the capacitor a test anyway. Now my red leader is hanging by 1 strand right down here. It's ready to give up the ghost, so not that that matters. I've got other clips. It's going to come off right in the middle of this test. That's okay. 50 volts, watching the eye. What do you say? And the eye is still closed right up. So unfortunately, we don't know what this capacitor is doing for sure. It's connected to ground, so it's probably trying to filter something out, get rid of something, get rid of some signal, something like that. It's trying to ground out some signal there. So what I've done is I have hooked up the decade, no, it's not a decade box, the capacitor substitution box. It's just this side, this resistor side, doesn't matter. And I've set it to 0.05. I'm going to run the radio and I'm going to change the size. Who knows what might happen? Nothing should. Who knows? Let's find out. Here we go. Radio is switched on. That's the tone all the way up. Volume is partial. And, you know what? I'm going to need to hook up the antenna here. Turn the antenna on, rather. Okay, well, this is warming up. I'm going to run and turn on the antenna down here. So you just watch that radio. Tell me if there's smoke. Freaks out my cats when I run through the house like that. Okay, hearing nothing? Oh, how come we're hearing nothing? Oh, I know the problem. It's a basic problem I run into all the time. I didn't plug it in. I'm not plugged in. Not plugged in. Where's the plug? Here it is. Okay, let's try this again. There we go. So no smoke could have come out of this. So thanks for watching anyway while I was running through my house. Let's get these tools out of here. Okay, you can see the dim bulbs over there. Any volume yet? Oh.
It remains significantly higher than 4 years ago when there were 61 shootings. President of the National Police Federation, Brian Sovay, says officers are facing increasingly dangerous situations.
No cop that I have ever dealt with wants to go down this road.
Criminologists say officers need more training and oversight. Kelly Malone, the Canadian Press, Saskatoon.
So without revealing any too much personal information, my brother-in-law was a police officer in the city of Toronto, right downtown. He spent his whole career in 1st 52 Division, which is right downtown Toronto, and then out to the West End in another division to finish off his career. And when he retired, I was with him, and somebody, I can't remember who, somebody asked him, did you ever shoot your gun? And his response was, I never took it out of the holster. His whole career, he never took his gun out of his holster. Now, I don't know if that's the truth. I think police try to protect their relatives and whatnot from becoming too involved in the horror stories that they face all the time when they're doing their job. So maybe that's his stock answer, but that's what he said. He said it so matter-of-factly. Never took it out of its holster. Wow. I'd say that's a pretty successful police career. Yeah. There we go. Let's tune it right in now. Okay, during the traffic report, we will go bigger first. And bigger yet. Much bigger. Okay, we'll go back and forth. I don't hear any problems. Okay, now we're going to go smaller.
We're just getting word now of a problem on the westbound QEW. It's the ramp
Smaller.
to Contra. Apparently the right lane is blocked, and that is
1/10
because of a
its size.
vehicle. And if you're traveling right now on eastbound,
I'm going to go back and forth. Do we hear any difference?
At the 403, we've got a disabled vehicle. The right lane is blocked. Emergency
So I stopped in between by accident there, and the radio got quieter. So let's do this. What if there's no capacitor? Quieter.
Okay, temperatures today get up to about +2 with all that cloud cover.
So even that 1/10 the size is having the, I think, the desired effect on the radio.
Watching the thermometer very closely, and for tonight,
I think there's a slight volume change there.
-3. Now, as we go into the day on Sunday, it is going to be cloudy.
It's a tiny, tiny capacitor. So any amount of capacitance having a significant effect. Okay. Power off. There we are. I'm going to stick a .05 back in there. And we'll carry on. Oh, I neglected one thing here, and that's to measure the voltage across this capacitor. Since again, I don't know really where it is, I'd like to know what its voltage drop is, or what voltage it's sustaining, so I can pick a good capacitor for it. Let's get my voltmeter here. The leads are all tangled up here. That's what's going on. There we are. Voltage.
And Hockey Hall of Fame are both open with regular hours. At Centennial Park Conservatory, the Winter Flower Show is open all weekend long. For a full rundown of weekend events, you can head to our website, toronto.citynews.ca.
And make contact there.
Sorry, there finally is the forecast. 680 weather specialist Denise Henriachi says it will also be chilly New Year's Eve. Near zero for New Year's Eve, but some flurries in the forecast. conditions through your New Year's Eve.
minus
We're not expecting
half a
a
volt.
large amount of snow. You can expect
Really?
sunshine through the first week of 2024 and above seasonal temperatures.
Yeah,
New Year's Eve celebrations are happening.
minus half a volt. So a low voltage capacitor is going to do the trick there.
On the Toronto
Good.
festivities.
That's just what I needed to know. Okay, we're going to put a capacitor in there and be done with that one. Okay, sometimes when I'm working here and not shooting the video, I've got my ham radio receiver going, listening to the local guys chatting. So here we are. Got that there. This camera a mile away. So next, now this is a 100 volt capacitor. So when I say low voltage, I don't mean that low. Okay, just in case you're wondering. Now, next capacitor to do. Okay, I'm gonna pick on this one. This one I'm pretty sure I can identify. So it's coming off the tone control. It's coming off. So there's 3 terminals on the tone potentiometer. It's coming off one of the outside ones. And there's a wire coming off it, going to a resistor here in brown, black, orange, which is 10K. So you should find it. Capacitor, tone control, 10K resistor. That's what we're going to look for on the schematic. Now I did post a video yesterday or the day before of my cat's x-rays and discussed it a little bit. Since that x-ray was taken, he's had subsequent treatment and another x-ray. And what you can see in the x-ray I showed in the video, I'm just telling you this in case you watch this video and wondering what's happening with my cat. The amount of poo is down. The vet managed to get some of the poo out of him. So he's still got a big lump in there, which we're going to work on today here at home with various fluids, basically. I won't go into it any further than that. Okay, enough of that. But Peanut is not near death or anything like that. Okay, he's just in a bad way. So okay, just in case, because I know I get emails from people talking about my cats because they appear on my videos now and then. So you're probably just wondering. Now, get back to what we're doing. It was tone control. Okay, here's the tone control. It was a lead with a capacitor and a 10K resistor coming off it. Well, that's interesting because here's a 22K. Wait, whoa, no, not interesting. Stop that. 10K, 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 right there, jumps right there in front of you. 10, the M really means K on these older schematics. So there it is. There's the capacitor. It's a 0.05. Now, what is it doing? So this volume control has an extra tap on it here. This is a tap, a non-movable tap. Usually these things are involved with tone control. Sometimes feedback, negative feedback injection takes place here, I think. The effect of it is to create a loudness effect, which is a special word I'm using here. In the world of stereos, when you turn the volume low, the bass and treble get a boost right at the bottom there. And that's to compensate for our hearing. A human hearing at low levels can't hear low tones and high tones well. That's because our hearing focuses in on the voice range under low volume circumstances. So that's to affect that. Now, is that what this is doing? I don't think so, but I don't know, to be honest with you. I don't follow how these work exactly. I just know this is the engineer's playground with this kind of stuff. They have fun with it. So there's the 0.05, or a capacitor. It's a 0.05 on here, and it's probably exactly what it is in the radio too. And one end goes to a grounded terminal, so we're going to have to prove that out. One end goes to a grounded terminal. Wait a minute, the bottom of the volume control is a grounded terminal. Okay, that doesn't really matter. let's go back to the radio. Okay, this guy, one end, well that can't, that's not where it's going. Is this a grounded terminal? That's a good question. Let's find out. Too many tools laying around. Okay, are you grounded? That would appear to be the case. Okay, that has got to be the capacitor. Wow, I got one to match the schematic. It's amazing. It's amazing. Okay, we'll cut them out. And it says 0.05. Now, I gotta look back at the schematic. What kind of voltage is that thing subjected to? Probably not a lot, but let's look. Okay, so you just wouldn't expect a lot of voltage around the volume control, but let's just track it out here. So bottom of this, minimal DC flowing in here, I would think. Well, none, because of that. Well then, if you've got a capacitor here, I think that means the only thing in here is the audio signal. There's no DC. What about coming back? Like, they wouldn't want DC coming back on the grid here, so ground. No, there's nothing here. This is grounded, Jim. That's grounded. And this guy's grounded through the capacitor. It's on the plate, but the capacitor is blocking it. Voltage. So no voltage here, so I can put a low voltage 0.05 in here. Now let's mess around. I'm going to put different sizes in here with the capacitor box, and we'll just see what happens here. Because I think this is the tone control here. This guy's just providing maybe a signal ground and not providing a DC ground. It doesn't make sense. Okay, I'm not going to try to analyze this too much because whatever I come up with will be wrong anyway. So, okay, let's stick the decade box in there. Okay, it's not a decade box, Jim. Come in. Okay, we'll set it to the size of the capacitor that's there now. Okay, I'm going to power up the radio. Away we go. Okay, so we haven't tested this yet. 0.05. Oh.
The death toll is expected to rise as an unconfirmed number of people are still missing. Search and rescue efforts are expected to continue throughout the weekend.
Where's that? I missed where that was. Okay, so there's the tone action. Really muffles it. Lots of treble coming through. We'll leave it up high for treble. We'll start fiddling with this. Going bigger first. Turn it up a little bit.
Across 6 cities in Ukraine since the war began. Western Russia has come under regular attack from drones since May. Russian
Back to the regular size.
Kyiv, but Ukrainian officials have not claimed responsibility for the drones. Police are ramping up security efforts across Europe to keep people safe during New Year's Eve celebrations.
So I didn't hear any difference. Let's go smaller now.
Police and military personnel will be deployed on New Year's Eve. The tight security in part because of heightened tensions over the Israel-Hamas war. French officials say people will be body searched before entering certain festivities, and drones will be used to monitor the crowds. Berlin too is beefing up security to try to avoid another volatile New Year's Eve like last year. Rioters attacked police and emergency workers with fireworks and other objects, and there are pro-Palestinian demonstrators who have scuffled with police in recent months.
Can't hear any difference, so I'm going to remove it now.
Germany emergency crews
We'll see what
posted a social
happens.
media video reminding people to respect the police and firefighters working to protect them on New Year's Eve. Coming out, traffic and weather together.
With so many amazing features made for winter adventures, the Honda CR-V Touring Hybrid has something for everyone these holidays. Jack Frost delights in heated front seats. Rudolph loves the LED headlights. The Grinch over the moon about its fuel efficiency. And his little dog Max is just happy to have some extra help with the two-motor hybrid engine. Bring home the 2024 CR-V Touring Hybrid and bring home something that...
Okay, well that's interesting. You gotta start wondering, what are they putting these capacitors in these radios for? Anyway, so this one didn't seem to matter what size. Of course I'm limited, I can only go up to a 0.2. But from a 0.05 to a 0.2, you know, that's a substantial change. And all the way down to a 0.0001, and in the end nothing. Made no difference in the operation of the radio. Why did they put it there? Okay, I'm going to replace that one now. Okay, hold on a minute. I got ahead of myself here. So turn the radio back on. I say I turned the radio back on. Good.
Maybe a little bit new, and then temperatures tonight dropped down to -3 for an overnight.
I had the tone control at maximum high. I'm going to put it at maximum low.
Cloudy conditions, 0 will be the high.
Really, minimum high is really what it is. Now we'll listen.
And it's really not going to lead to much accumulation at all. Just really kind of helps set the mood for New Year's Eve. And then we go into Monday, sun and cloud and 0, and then sunshine on Tuesday and 3 degrees.
Oh,
right now, it
that's
is
a
0
difference.
at Pearson, also 0 in downtown Toronto, and our guaranteed highs +2.
And coming up at 11:30, we'll have more on New Year's Eve festivities. It's tomorrow. The city of Toronto and other municipalities are busy preparing several events, several fireworks displays. We'll have all you need to know coming up. City News Time, 11:23.
This is the sound of vacationing. Woohoo! And this is the sound of booking a sell-off vacation. Woohoo! Sounds similar, don't they? That's because booking a sell-off vacation comes with that extra special feeling. You know the feeling. The overwhelming feeling of pure excitement, knowing this beach time is just around the corner. And that this savings. Big, big savings. Wait for less. Never felt so good. We have seen it all. Providing details.
City News Time, 11:24. In the U.S., millions of Americans are flying this New Year's holiday weekend. ABC's Rena Roy is at New York LaGuardia Airport.
The TSA says it's been steadily busy this holiday season with 2.4 million passengers or more.
Okay, so what I think is happening there is the capacitor is affecting the lower tones, and it's involved with the tap on the volume control through that resistor, and so it's affecting the tone that way. Well, that's a terrible explanation. Let me do a little better one. When the volume is turned low, the wiper is near the tap on the volume control, and so anything you shove in through the tap or affect on the tap is going to come out of the speaker. You're going to notice it. Whereas when the volume's a little higher, mostly what's entering the audio circuits is based on the slider being farther up on the potentiometer away from the tap. So what you do with the tap doesn't make much difference. I don't know. that's my kooky thinking. Like I say, this part of these radios, engineers just mess around with like crazy. I think this is the rest of it is kind of, the math tells you what to do. But this part is all about the sound quality, audio, and stuff like that. And I think they fiddle around with it a fair bit. So, engineers special. Power's off again. I'm going to put in that capacitor. Oh, we got to test this one. Anybody want to take a guess at what it's going to show up as? And the guess is, let me tally up the votes. And the votes say it's going to show up leaky, even with 50 volts on it. Now you might have been able to read that this actually says 25 volts, but by measurement it's actually 50 out here for some reason. Okay, we're ready on the eye. Here we go. Okay, everybody who thought the capacitor would show up very, very leaky won the bet. Everybody, exchange your money now. There we go. I could become some kind of broker here, some kind of gambling broker. Put your money down. Right, okay, I'll change that capacitor now. Okay, ready for the last test of the day. I've got the capacitor installed there. Good. Lean down a bit. Power on. There we go. Up. Tone high. I'm going to give it the full voltage here.
A maximum range of 521 kilometers leads most in the segment. On the road, the Blazer EV offers a smooth, quiet, and comfortable driving experience. Bursts of acceleration when needed. The cabin is nicely designed, and its standout built-in Google-based 17.7-inch infotainment system impresses with intuitive voice operation.
Low volume tone. Speaker's not in its cabinet, so it's not going to reproduce, it's not going to provide as much bass.
A powerful storm continues to pound the west coast this weekend. California is still being battered with massive waves and flooding. CNN's meteorologist Elisa Rafa has more.
As we go through the holiday weekend, waves have been crashing the last day or so, with some wave heights up in the San Francisco Bay Area already measuring up to 28 feet, and they could be even higher than
28
that
feet.
Saturday. The Weather Service calling this event exceptional, one that we haven't seen in many years. We've got strong winds that's moving around the water, creating some of those waves. Plus, you have an ocean current that's doing that as well. So sometimes you get those waves to kind of crash and collide, and it could create a rogue wave. That wave winds up being 2 times or more bigger than all of the other waves around it, and it can be very unpredictable.
The storm is expected.
Okay, that's far away from here. That's way out on the west coast. Far away from here. But I did see a video of one of these rogue waves, or sneaker waves. Sometimes they're called sneaker waves. Really putting a lot of water where no one was expecting it. Quite something. Okay, so that's it. So I got a couple more capacitors done. Thank God I got something done finally. Got this guy, the mystery guy. I'll take a look at him tomorrow. I got the big one back here. Turn the power off before you stick your finger in there. And I'll bet you there's 1 or 2 more wax capacitors buried way back in here somewhere. Just don't know that for sure, but good. We're going well. Things are going well, actually. Fantastic. So thanks a lot for watching. Hope you're getting a kick out of this, and I'll be back in here tomorrow. See ya.